Good afternoon, all. Can you hear me? One, please.
Yes, sir.
Today we'll discuss something about that some numerical, how to solve some numericals related to that wind turbine. So one of my project student as well as PhD student, he will guide you. Just a minute. We'll be joining another 10 minutes. And before going over there, I wish to tell you like some topics are provided there in the Google Classroom for 6 semester students. So there maximum 5 students are allowed. Few topics will be provided later related to some solar energy. And the topics which I provided till now, those topics are good according to that research point of view. So there you discuss yourself and uh, you know, form groups, then plot over there in that Excel sheet. One. Then in solar energy, like few topics are there, kind of like solar cooking, then solar energy utilization in electric vehicles, solar water pumping, and then data analysis using MATLAB or some optimization techniques or some machine learning, then solar irradiance forecasting. Other than this, some topics are there in wind turbine, wind energy also, kind of uh, wind energy assessment technique. Then that one, wind power forecasting, and that power performance analysis of vertical axis wind turbines by attaching some different profiles. Then effect of multi-cavity on power performance, effects of the operating ratio and cavity on the power performance. But for that, no, one must know that analysis software. CFD is also fine if you know CFD, and if you know SolidWorks, then that design part you can go over there, and analysis part you have to do there in the Computation Pro Dynamics, the ANSYS platform. And one more thing, like there where I have collected the software nodes by you, they are like a maximum of like few students. They know that ANSYS, SolidWorks, those kind of softwares. And suppose there are 10 students who knows ANSYS or CFD, then do not come in a 2 groups or 3 groups. What I wanted to say is like divide yourself like two students in each groups. And for SolidWorks team also, like 2 students will be there in a group. Another 2 student will go there in another group. This way, you just share yourself. So in a group, like if 5 of you know that different 5 or 6 softwares, so that will be easier to work. Got the point? And for eighth semester students, final year students, the topics are already provided to you. And so you have to do the work in a solid way as it is your final semester. And one more thing, like the students who will be working in this mini project, you can do the same topic or you can extend this topic for the next semester also. Like, yes, I'm taking that power plant engineering subject. They are in the 7th semester for BTech or MTech first year. So here also you can continue the same topic. Okay. So there will be same topic. It will be there, but the work it will be different. There in 7th semester level, there it will be some higher level work we can do if you do some preliminary work over here. Right? So one more thing, there I won't be allowing those who are not taking this renewable energy subject for power plant engineering. So I'll put some criteria over there. The students who are taking renewable energy sources subject, they will be only allowed to take the power plant engineering subject. Power plant engineering, like there it will be these renewable energy sources or sustainable energy sources. These topics, it will be there like solar, wind, hydroelectric. Other than this, that coal-based power plant, oil-based power plant. So those it will be there also. Other than renewable sources, it will be covering almost all the power plant related to our mechanical engineering. Thing. So okay then, do this one accordingly. Yogesh, are you there?
Yes, sir. Good afternoon, sir.
Good afternoon. So he's your Yogesh sir be handling this one for this numerical part. So they are in the Excel sheet. So another topic, like solar energy related, it will be there. I have told you of topics, it will be there. And these are good topics. And that some video links I have provided there in the classroom also, whole classroom, and some papers also, some related papers. You can go through that papers. That papers are related to this MCDM and PSO, particle swarm optimization, and then Open LCA, wind power forecasting, and solar irradiance forecasting. Those kind of papers I have up in there for that. And while you are this one filling this Excel sheet, so do not please do not try to do some extra curriculum. Like that time, no, like 30 minutes before, someone has added that some sheets, additional sheets, like sheet number 6, 7, this way. Day before yesterday also I've seen some students are doing some activities. So whatever it is asking, do that one only. Otherwise, if you manipulate this one, it will be difficult to rearrange this. Like if someone is typing over here instead of software, if someone is typing this one with some other word, then please cooperate with this. Then okay, hand over to Yogesh sir. Please Yogesh,
Thank you, sir.
you can share the PPT. So here someone rule number 15, you are asking, Ayush Srivastav, you are asking for each topic maximum 5 students or maximum 5 teams are allowed. For each topic 5 students, okay. Maximum 5. So minimum it will be 4, 3 also, 2 also. It is not mandatory, it should be maximum level, okay. Maximum is 5. So okay then, Yogesh, you can carry on.
Yes, sir. Good afternoon, students. Today we will discuss some numerical portion of the wind turbines. So first numerical is here. Please read this numerical and type in your notebook. So in this numerical, a 40-meter diameter, 3-bladed wind turbine produces 700 kilowatt at a wind speed that is at hub height of the wind turbine of 14 meter per second. Means free stream velocity is 14 meter per second. And the turbine produces 700 kilowatt with a diameter of 40 meter. And the air density is 1.225 kg per meter cube. And we have to find that the rotational speed in RPM of the rotor at a tip speed ratio of 5.0. So you write down complete numerical in your notebook and then we'll go to next slide.
Devesh,
Yes, sir.
you have to take attendance now.
Okay, sir.
Like you can ask other students to join this class as soon as possible. If you are having that WhatsApp group, you just put SMS over there. Put an SMS over there. Ask them to join immediately.
Okay, sir.
So in first part, the rotational speed of the rotor in RPM at a tip speed ratio of 5. So to calculate rotational speed, we have a formula for tip speed ratio. Lambda equal to omega r by u. Here u is free stream velocity and r is radius of rotor and omega is rotational speed or angular velocity of rotor. Here tip speed ratio is given 5. So lambda equal to 5. And diameter of turbine is 40 meter. So here r radius equal to 20 meter. Now calculate omega rotational speed of the rotor, lambda u by r. So calculate and match this value. Now this omega is in radian per second and we have to calculate rotational speed in RPM, round per minute. So we use formula for omega. Omega is equal to 2 pi n rotor divided by 60. N rotor is rotation per minute and rotor in RPM. So we calculate n rotor equal to omega into 60 by 2 pi, which is equal to 33.42 RPM. So now in part B, what is the tip speed in meter per second? Tip speed in meter per second. So we know the formula for blade tip velocity, u tip equal to omega into r, which is tip speed ratio is equal to lambda equal to omega r by u. Blade tip velocity divided by free stream velocity, which is tip speed ratio. So we can calculate blade tip velocity u tip equal to omega into r. Here omega is equal to 3.5 radian per second and r is equal to 20 meter. So we get the value for u tip equal to 70 meter per second. Calculate its value and match it. Now in part C, if the generator turns at 1800 RPM, what gear ratio is needed to match the rotor speed to the generator speed? So here generator RPM is given 1800 RPM. So we have to find gear ratio. And we calculated RPM of rotor 33.42. So we can calculate gear ratio from the formula N generator divided by N rotor. Here N generator is RPM of the generator divided by N rotor, RPM of the rotor. So we get RPM rotor 33.42 and RPM of generator is given here 1800 RPM. So gear ratio is 53.86. By dividing this 1800 divided by 33.42. Write down all these formulas in your notebook. So now part D. What is the efficiency of the wind turbine system, including blades, transmission, shafts, and generator under these conditions? Now we have to calculate efficiency of the wind turbine system. So by using this formula, power equal to eta Cp. Here eta is efficiency and Cp is coefficient of performance for wind turbine. And rho is equal to 1.225 kg per meter cube, which is for air, and A is swept area for vertical wind turbine, and U is free stream velocity. So here diameter is given. So we calculate area, swept area for horizontal axis wind turbine, and density is also given. Here we assume Bayes limit Cp equal to 16/27, which is maximum. So area is given as pi r square, and eta is efficiency, rho is density of air, Cp is coefficient of performance for wind turbine. So we use this value 16/27 for Cp. U is free stream velocity, which is given as 14 meter per second. So calculate efficiency value and match this value by using all the values given in question. Here power is given 700 kilowatt. From this formula, we get overall efficiency of the turbine, which is 0.56. Because in question, here efficiency for generator, shafts, and transmitter or blades are not given. So this value for efficiency is overall efficiency. This formula is important for power calculation in wind turbine. And A is swept area. Horizontal axis wind turbine swept area is pi r square. So now next question is, it is simple question based on previous formula. Find the size of a wind turbine rotor, diameter in meter, that will generate 100 kilowatt of electrical power in a steady wind hub height of 7.5 meter per second. Assume that the air density is rho equal to 1.225 kg per meter cube and Cp is given here 16/27 and efficiency equal to 1. So note it in your notebook and try to solve it. It is simple numerical based on only this formula. Power equal to efficiency into coefficient of performance into rho A U cube by 2. So in this question, we have to find the size of wind turbine rotor, that is diameter in meter. And here is given the turbine generate 100 kilowatt of electrical power in a steady wind of 7.5 meter per second. So free stream velocity is 7.5 meter per second. Assume that the air density is 1.225 kg per meter cube and Cp is also given 16 by 27 and efficiency equal to 1. So we know the formula for power. Power equal to efficiency into coefficient of performance Cp into rho A U cube by 2. So again, we can calculate swept area A by using the formula pi r square. So use this formula and solve this for diameter D and match the value 28.8 meter. This is simple calculation. So calculate fast and type in chat box. Type your answer in chat box. Mostly students get the value 28.84 meter. So approximate 28.8. So now in next class, we will discuss here in these question, we use TD wind of 7.5 meter per second. But how we calculate this value? So in next class, we will discuss the wind speed estimation for different surfaces. So we use some methods, that is logarithmic profile, log law, and second method power law. So in logarithmic profile, we use the formula uz by uzr equal to log of z by z naught divided by log of zr by z naught. So here z naught is the surface roughness length and z is the height for which we have to calculate the wind speed, and zr is the reference height. So for this z naught surface roughness length, we use this table. Values of surface roughness length for various types of terrain, that is very smooth or ice or mud, we use z naught equal to 0.01 mm. For calm open sea, 0.20 and so on. So according to question, we have to calculate z naught value to estimate the wind speed for different heights. So in these type of questions, we use logarithmic profile law or power law. So we will discuss this question in next class.
One minute. Students, please wait. So you fill up that Excel sheet accordingly, okay? Try to complete it by today evening. Okay? And
Excuse me, sir.
the links which I have provided there in the Google Classroom, we can go through that one also. You can refer that. You'll get some
Sir,
overview. Yes.
so actually there are six topics. So is it that one topic is to be taken by multiple groups, or you will be giving more topics?
Yes, it is mentioned there. No, I'll be giving more topics on solar energy and wind energy. Solar energy kind of that solar cooking and solar energy utilization there in electric vehicles. No, that is no kind of like simulation and analysis work you have to be has to be done over there. Then solar water pumping, data analysis, using MATLAB and some renowned optimization techniques, that solar energy forecasting and wind energy forecasting and some wind turbine blade design and its analysis. So some topics are there also. Don't know.
Okay, sir.
So okay then, there are two groups have selected for that one, life cycle assessment, and one is MCDM. So okay then, just look for this one, this topic first of all. Anything else? That's all. Okay.